Hello children, welcome to Chemistry. So this is my first video and I'm going to take up the ICSE class 10 previous year question papers for the discussion because we have in couple of months ICSE board exams. So this is year 2023 and I am following the 2023 syllabus given in the ICSE website. Okay, so if you don't know what is there, you can go to ICSE website and check. Okay, and whatever not there in the syllabus, we are not going to touch those questions. Okay, so once again, welcome. This is a 2020 question paper. So we have obviously you know the things already. You have 2 hours to write. There will be section 1 where all the questions are compulsory, and in section 2 you have to attempt any 4. So in section 2 you'll be having 6 questions. So out of this you only have to attempt 4 questions. Okay. Okay. So let's take the first question. You can see question number 1, multiple choice questions. The element with highest ionization potential. So you already know what is ionization potential. Ionization potential is also called as ionization enthalpy, ionization energy. It has different names, but it indicates the same thing. So ionization potential is how much energy you need to remove an electron from its outermost shell. So therefore it is the energy needed, means if you are giving energy to the substance, then that will be positive, means endothermic. Okay, so therefore ionization potential is the energy needed to require an electron from the outermost shell, which will be positive. But what they are asking here, highest ionization potential. So you can see here what are the elements given: hydrogen, cesium, radon and helium. For this you need to have the idea, or you need to understand about the trends of ionization potential along the period down the group. So down the group ionization potential decreases, across the period ionization potential increases. Okay, so obviously not cesium, because you're going down here, hydrogen, here cesium will be there. Across the period means helium, so obviously helium should have, and radon will come here. Okay, so again as you are moving down ionization potential decreases, therefore your answer should be helium. Or you can also remember the element with highest ionization potential is always helium, no other element. Okay, hope it's clear. Let's go to the next question. The inert electrode used in the electrolysis of acidified water. So this is one of the electrolysis processes we studied. And inert electrode, we have two things. One is platinum, another one is graphite. So straight away, if you observe any options, either platinum or graphite, straight away tick one of them. So here it is platinum. One more type of electrodes are, do you know what are those? We call them as active electrodes. Very good. So active electrodes will be the metals it themselves, except platinum and graphite. Okay. Anyway, graphite is a non-metal. So nickel, copper, silver, if you use, those will be active electrodes. Active and inert may difference. What is the difference? Active, they actively take part in the electrolysis, but inert, they do not take part in the electrolysis process. Do not take part in electrolysis process. Okay, go to the next question. A compound with low boiling point. So if you see the options, you have sodium chloride, calcium chloride, potassium chloride, carbon tetrachloride. So here you have to observe. You can also use odd one out concept also, but if you observe here, these three are ionic compounds, which are also called as electrovalent compounds. Okay. Carbon tetrachloride is covalent compound, CCl 4. Carbon tetrachloride is this CCl4 ka common name. Its IUPAC name will be what? Tetrachloromethane. Okay. And ionic compounds, because of strong electrostatic force of attraction, they are strong bonds. Ionic bonds are strong bonds, covalent bonds are weak bonds. Therefore, to break a strong bond, you need more energy. Means the ionic compounds will have high melting point and boiling point, and covalent compounds will be having low melting point and boiling point. Therefore, here the low boiling point is this one. The same question may be asked in a different manner. A compound with high boiling point, there will be 3 options of covalent compounds and 1 option of ionic compound. Okay, then ionic compound will be the correct answer. Next question. The acid which can produce carbon from cane sugar. Okay, the acid. So we have all the types of acids here. Hydrochloric, nitric, sulfuric, acidic, all are concentrated. Now we should know the nature of sulfuric acid. Sulfuric acid concentrated form, it's a non-volatile acid. It's a dehydrating agent. We learned about this in even grade 9, right? Dehydrating agent means it will take away water molecule. Okay, then it can also act as oxidizing agent. Okay, so and if you see nitric acid concentrated, it can act as oxidizing agent. Hydrochloric acid is only acting as acid, sometimes reducing agent also. Concentrated acetic acid is a weak acid, so don't worry about it. Okay, so cane sugar is nothing but sugar only, C12H22O11. From this you have to get the only carbon. How? I can also write this C12H22O11 like this for our understanding. H2O11 means it contains water molecules, and what you are going to add? Dehydrating agent. What is that? Sulfuric acid concentrated, very important. Diluted one will not act as a dehydrating agent, remember. So it will take away water molecules, so you will get 12 carbon atoms and 11 water molecules which are absorbed by sulfuric acid. Okay, nice. Next question, the organic compound having a triple carbon-carbon covalent bond, C123C. This is a carbon-carbon triple bond. C, if there is a there are two lines means double bond. A single line represents a single covalent bond. So to know this, you should remember the general formula of, if there is a single bond, this is called as alkane, this is alkene, this is alkyne. Okay, so alkane का general formula CnH2n plus 2, alkene CnH2n, alkyne CnH2n minus 2. So you have to keep on reducing 2 hydrogens. So alkanes reduce 2 hydrogens, alkenes reduce 2 hydrogens, alkynes. So out of these 3, out of 4 options, which molecule fits into this general formula? That will be the correct answer. Okay, if you check C3H4, C3, 3 carbons, so 2 into 3, 6 minus 2, 4. Yes, the first one is correct already. If you check, other options will be wrong. Okay, so this is question number 1. Children, I'm going in detail so that you can understand, or if you forgot some basics, you can get them, you can remember them or memorize them once again. Okay, let's go to next question. State one relevant observation for each of the following reactions. Very important question. Definitely there will be a question on observation. Always remember, observations means what they are asking you is visible changes. Visible changes means there may be change in color, there may be any gas evolved, it may be having color or do not, okay, it may be colorless, or any precipitate formed, and if it is forming, what is its color. These will be your observations. If there is a colorless gas evolved, then you have to write the test for that. Okay, we'll see that. Here first one, action of concentrated nitric acid on copper. Okay, I will tell you one trick here. Remember, whenever you take concentrated nitric acid on any element, okay, usually in your syllabus you have copper, carbon and sulfur, so they may just change the element. Okay, so always the observation will be reddish brown gas released. Okay, how? Because concentrated nitric acid is an oxidizing agent, so it oxidizes the elements. Okay, and when it oxidizes the element, it itself will undergo reduction, and for concentrated nitric acid, reduced products will be NO2 plus H2O. Remember, it is also important when they ask you to write the balanced equation. Okay, so here copper will oxidize to copper nitrate, plus you will get NO2 plus H2O. Same thing happens with carbon and sulfur. Okay, so the observation will be reddish brown gas released. So straight away, if there is a constant nitric acid with any element and observation, reddish brown gas released. That's what you have to write. Next, addition of excess ammonium hydroxide into copper sulfate solution. So this is a part of analytical chemistry, so you need to remember the color of the precipitate. Okay, but here remember, addition of excess, right? So what is there? Ammonium hydroxide and copper sulfate. So ammonium hydroxide is this, copper sulfate is this. Initially what it forms? Copper hydroxide, okay, and which is a pale blue precipitate, okay. Now the question is, excess means you are again adding ammonium hydroxide to this excess. Then this pale blue precipitate will dissolve and form deep deep blue solution, or they also call it as inky blue solution. Inky blue solution. Okay, so you have to write both here. What? You should not just write the inky blue solution form. No, because that is not formed directly. It passes through the pale blue precipitate, right? So initially pale blue precipitate formed, which dissolves in excess whatever ammonium hydroxide solution to form inky blue or deep blue solution. Okay, this should be your complete sentence, so then you will not lose any marks. If you simply write deep blue solution formed, you may lose marks. Okay, don't take the chances. A piece of sodium metal is put into ethanol at room temperature. So this is in alcohols, so which is not there in syllabus for 2023 syllabus. Okay, let's go to next one. Zinc carbonate is heated strongly. Zinc carbonate, when you heat it strongly, okay, zinc oxide and carbon dioxide gas is released. It's just like decomposition of any carbonates. You will get metal oxide and carbon dioxide gas will be released. Here you can write observation with carbon dioxide gas, which you know, lime water test, but lime water test is also shown by SO2 gas. Okay, so you have to differentiate between the two. There is one more test, acidified KMNO4 solution, no effect If we use carbon dioxide and acidified KMnO4 solution, no effect. But SO2 will change the color from pink to colorless. Pink to colorless for acidified KMnO4 solution. There is one more test, acidified K2Cr2O7, that is potassium dichromate solution, which turns from orange to green in case of SO2, but no effect by SCO2 gas. This is one observation. Or you can also write zinc carbonate is white, zinc oxide when it is hot it is yellow, and when it becomes cold it again becomes white. You can write that observation as well. A hot yellow residue formed, or you can write yellow residue when hot which turns white on cooling is formed. That also will be your observation. Okay, any one observation. Sulfide ore is added to a tank containing oil and water and then stirred and agitated with water. Again, this will be the steps of or the methods of concentrating the ore, which is not there in your syllabus as of now. We have lots of things. Okay, so froth flotation process, this is basically froth flotation process. That's not in the syllabus, so let's leave it. Let's take the C question. Write a balanced chemical equation for each of the following. I know most of the students do the mistakes here because here they are giving you the descriptions, not the skeletal equations. So we'll try what kind of tricks we can use here. Okay, reaction of carbon powder and concentrated nitric acid. Again, if you see, previously I told you here concentrated nitric acid is a powerful oxidizing agent. So obviously what you should get in the product side, NO2 plus H2O. Okay, I will just give you the skeletal equation. Anyway, you know how to balance. If you're in grade 10, you should know how to balance it. Okay, so carbon is C plus concentrated nitric acid HNO3, and whenever you're writing the chemical equation balanced, always write whether it is concentrated or dilute. Okay, many people lose marks for not writing this. Okay, I'm just showing it here, sorry for that. Here carbon will be oxidized to carbon dioxide. Okay, and concentrated nitric acid will be reduced, so reduced products are NO2 and H2O. So this is your skeletal equation. So this thing you have to balance. Okay, I'll just straight away write you balanced here. 4 HNO3 you need, and you will get 4 NO2 and 4 H2O. Okay, but it is important to arrive at the skeletal equation because you know how to balance already. Reaction of excess ammonia with chlorine. This is very interesting and definitely one question will be there on this. Okay, ammonia and chlorine. Here ammonia is acting as a reducing agent. Okay, there are 2 points here. In one case we use excess ammonia, another case is there where we use excess chlorine. So sometimes they will ask you to write for reaction of ammonia with excess chlorine. Okay, that's why I'm writing you here. When excess ammonia is used, okay, so you will get nitrogen plus ammonium chloride. Nitrogen plus ammonium chloride. When you use excess chlorine, okay, you will get NCl3, nitrogen trichloride plus HCl. This is the difference. Okay, so here ammonia will, you are using in excess, it will completely gets oxidized to nitrogen. Okay, and ammonium chloride will form. You can also write observation if they ask you why dense fumes here. Ammonium chloride. Okay, here when you use excess chlorine, NCl3 will form and HCl will form. NCl3 is a yellow liquid, which is explosive in nature. So if they ask you to write the observation, then you can write that. Okay, so basically for this particular reaction, this is the equation which you have to balance. Okay, fine. Reaction of lead nitrate solution with ammonium hydroxide. Ammonium hydroxide, again precipitation reaction or analytical chemistry. So where I will write it? Okay, I will write it here. Lead nitrate, PbNO3 twice. Ammonium hydroxide, NH4OH. Okay. So you will get PbOH twice, which is a precipitate, plus NH4NO3. NH4NO3. So that will be your balanced equation. Not balanced, skeletal equation. So you just have to write here 2NH4OH. I think 2NH4NO3 enough. Yes. Next question, the balancing equation. Producing ethane from bromoethane using zinc copper couple in alcohol. Zinc copper couple in alcohol is called as reagent. In organic chemistry we have reagents. Okay? And this is one of the methods to prepare ethane from haloethanes. So very simple. What is here? The product is ethane and the reactant they have given bromoethane. Okay, let's write that. Bromoethane, CH3 CH2 Br. And what is the product? Ethane, which is CH3 CH3. It's also called C2H6. So this is just a structure. Okay. Now, conditions: zinc copper couple in alcohol. So you should remember that zinc copper couple in alcohol will give nascent hydrogens. Nascent hydrogen. And always nascent atoms are written in square bracket. If it is nascent oxygen, square bracket O. Nascent chlorine, square bracket Cl. Okay, so here to write here H. Okay, so obviously here how to remember this? See, CH3 CH2 Br is there and the product CH3 CH3 means Br is replaced by H, right? Okay, but what happens to Br? Okay, Br will combine with another H, that is you need two hydrogen atoms, so you will get HBr. HBr. Okay, that is your balanced equation. Okay, fine. Complete combustion of ethane. Now here you have complete combustion and incomplete combustion, two things. Complete combustion products you have to remember. Whenever any hydrocarbon is which one? Which contains carbon and hydrogens. Okay, whenever there is a complete combustion of any hydrocarbon, it may be alkane, alkene, alkyne. Okay, you will get always carbon dioxide and water. If it is incomplete combustion, instead of carbon dioxide you will get carbon monoxide and water. Okay, that's the difference. Incomplete, lack of oxygen, limited amount of oxygen, so therefore carbon monoxide is formed, which is a very poisonous gas. Complete combustion is when all of the carbon is oxidized to carbon dioxide. Okay, complete combustion of ethane, C2H6 is the ethane. For combustion what you need? Oxygen. So what you are getting? CO2 plus H2O. This is your skeletal equation. You have to balance this equation. Okay. If I do write here, you need 2 C2H6 O2, then 4 CO2 plus 6 H2O. Okay, fine. Now, very interesting question. Draw the structural formula for each of the following. There are three questions. 2,2-dimethyl pentane. Now, you know, always while writing the structure or naming the compound, you have to remember it made up of three parts: prefix, word root or root word, suffix. In suffix you have primary suffix and secondary suffix depending upon the functional group and all. Okay, now root word is which represents carbon numbers, number of carbon atoms. Prefix represents substituents. Suffix represents type of carbon-carbon bond. Okay, A for single bond, E for double bond, Y and E, wine for triple bond. or however you remember it. Okay, single bond, double bond, triple bond. Secondary suffix, if there is a functional group, say for example alcohol is there, then OL, aldehyde is there, AL, ketone, ONE, any acid, oic acid. Okay, so these also come in suffix, but we call them as secondary suffix. Fine. So here 2,2-dimethyl pentane. Pent is the root word, so draw the 5 carbon atoms here. Okay, let me just write here. Take some page. हाँ, ठीक है. 5 carbon atoms, 3, 4, 5, and 2,2-dimethyl. What this 2,2 represents? The position. Dimethyl means there are 2 methyl groups at the second position. So you can write here methyl, methyl. You can also write here. Nothing changes. So now what do you have to write? Write 4 bonds. Always carbon should have 4 bonds. Okay. And I will just erase this. I hope you written this one, because structural formula you have to show all the bonds. 4 H H H, here 1 2 3 H H, here H, here 1, here 2 3 4. For this carbon 4 atom, 4 bonds. For this 4 bonds. So this is your structural formula for 2,2-dimethyl pentane. Methanol. Meth means 1 carbon. An means single bond. Okay, means write 4 single bonds. OL is the suffix, secondary suffix for alcohol group. Means it has a alcohol group. And remaining should be hydrogens. So this is your methanol. Basically it is CH3OH, but structural formula to show all the bonds. Isopropane. So where this is coming from? See, this is called as a common name. Okay, we have two names, IUPAC name and common name. IUPAC, what we learnt, right? The rules. Sometimes they may also ask you the common names. Okay, some of the common names only. So remember isopropane. Okay, propane. This is actually a wrong question. Isopropane do not exist. No, because 1 2 3 iso means here one more should be there. Okay, it can be isobutane, not isopropane. So this question is wrong. So don't worry about it. Okay. So isopropane do not exist. Isobutane exists. Isopentane, isohexane, those things exist, not isopropane. Okay. Write the IUPAC name for the following. Again, you can see here they have given you common names. Okay, acetaldehyde. Acetaldehyde. Acet in common name is 2 carbons. Aldehyde means it has an aldehyde group. So they are asking you to write the IUPAC name. Means 2 carbons means eth, and all single bonds AN, aldehyde ka AL, ethanol. Remember, AL and OL will be confusing. Okay, always write them separately. AL. Okay, acetylene. Acetylene is a common name for ethine. Ethine, the first member of alkene, C triple bond C, H and H. This is acetylene. Okay, fine. Acetylene is used in the welding purposes. We call it as oxyacetylene flame. So you can, just for your information. Okay, next question. State one relevant reason for each of the following. Graphite anode is preferred to platinum in the electrolysis of molten lead bromide. Okay, electrolysis of molten lead bromide, PbBr2, liquid state. So when it undergoes electrolysis, you will get lead and bromine. Okay, so lead is a cation, so it will be released at cathode. Bromine is the anion, so it will go to anode. Means at the anode you will get bromine vapors. Okay, and if you use platinum, and because of higher temperature, I think it may be around 350 degrees Celsius. I'm not sure. If I'm wrong, please correct it. Okay, because of higher temperature, the platinum will react with bromine. Okay, and uh, we may not get the bromine. So if you use the graphite, it will not react with the bromine. Okay, so the graphite rods remains unaffected by the highly reactive bromine vapor compared to the platinum. So that should be your reason. Soda lime is preferred to sodium hydroxide in the laboratory preparation of methane. Okay, laboratory preparation of methane, we use sodium, not use sodium hydroxide, we use soda lime. So basically this is using the sodium acetate, CH3COONA, plus we use NaOH or quicklime. Okay, you will get what? Sodium carbonate will be removed, so you will get CH4 and plus Na2CO3. So this is called as decarboxylation reaction. Okay. Soda lime, how it got its name? Soda means sodium hydroxide, lime means quicklime. Quicklime is calcium oxide. Okay, so you should know sodium hydroxide is deliquescent. Deliquescent in nature means it absorbs the moisture from the atmosphere and dissolves in it. So we don't want any moisture in our reaction. Okay, therefore if you add the quicklime in sodium hydroxide, you will get what? The deliquescent nature of sodium hydroxide will be reduced. So for that purpose we use the soda lime instead of sodium hydroxide. Okay, hydrated copper sulfate crystals turn white on heating. Very simple. Hydrated copper sulfate is nothing but blue vitriol, that is copper sulfate pentahydrate, which is blue in color. If you heat, all the water will be escaped. So copper sulfate, which is white in color, will be formed 5H2. Okay, the reason is on heating the water of crystallization will break and water will evaporate or escapes from the crystal. So therefore we left only with copper sulfate, which is white. Concentrated nitric acid appears yellow when it is left for a while in a glass bottle. Concentrated nitric acid or pure acid is always colorless. Pure nitric acid is always colorless. But when you leave it for some time, what happens? HNO3, concentrated nitric acid, either in presence of some temperature or even in presence of light, it will decompose into water, NO2 and O2. Okay, so this NO2 will dissolve in concentrated nitric acid, so which is a reddish brown gas. So therefore that turns the concentrated nitric acid yellow. Okay, this turns the concentrated nitric acid yellow. So therefore the reason you can write this is due to the dissolution of NO2 gas in the concentrated nitric acid, which is formed by the decomposition of nitric acid when you leave it for a long time. Okay, hydrogen chloride gas fumes in moist air. Very simple. So you should know the nature of hydrogen chloride. Hydrogen chloride is highly soluble in water. Highly soluble in water. Okay, so because of that, in the moisture, when it dissolves, it forms the fumes. Okay, so therefore when it forms the fumes, what it contains? Hydrochloric acid. Therefore because of that, it forms the fumes in moist air because of its high solubility in water. Okay, okay, next question, very interesting. Calculate. In this I just want to tell you, in mole concept a lot of the portion has been cut down. Mole concept itself has been cut down. So in mole concept chapter you have only what? Gay-Lussac's law of combining volumes, you have Avogadro's law. Okay, this is for 2023 syllabus, and you have empirical formula and molecular formula finding, even the percentage composition. Okay, fine. So for that purpose this question is not there, this is not there. So first question. First question, if you read, the amount of each reactant required to produce 750 ml of carbon dioxide when 2 volumes of carbon monoxide combine with 1 volume of oxygen to produce 2 volumes of carbon dioxide. So everything they have given. Sometimes they will not give you the balanced equation, so from the description you have to make it. So basically 2CO plus O2 gives you 2CO2, and what they are asking you, the amount of each reactant, means CO and O2, both are the reactants, to produce 750 ml of carbon dioxide. Okay, very simple question. So here 2 volume of CO2, CO gives you 2 volume of CO2. So obviously if 750 ml of CO2 you should get, you need 750 ml CO, same amount, right? So here what? 1:2 ratio between oxygen and CO2. Oxygen and CO2 ka ratio 1:2. So obviously if you want to get 750 ml here, you need how many? 375, half of that, 375 ml oxygen. Okay. So this, because it is for, I think 1 2 3 4 means 5 marks, so it will be for 2 marks. Okay, so just have to explain. 2 volume of CO gives you 2 volume of CO2, therefore 750 ml of CO2 is formed by 750 ml of CO. Similarly, 1 volume of oxygen is required to produce 2 volume of CO2, therefore 375 ml of oxygen is required to produce 750 ml of CO2. That's it. State the law associated in question number F1. So which law we used here? Gay-Lussac's law of combining volumes, but they have asked you to state the law, not just to tell it. Okay, so state the law. You can just check the textbook. I will just tell you what is it here. So it is the law, Gay-Lussac's law of combining volumes, which states that when gases, these, it is only for gases. Okay, when gases react, they do so in volumes which bear a simple ratio. So if you see the ratio between carbon, CO and O2, it is 2:1. Okay, not only that, also it bears a simple whole number ratio with gaseous product, not the solid or liquid, only with gaseous product. So here 2:1:2, right? Provided everything at the same condition of temperature and pressure. Okay, so when gases react, they do so in volumes which bear a simple whole number ratio to one another and to the gaseous product formed under the same conditions of temperature and pressure. So this is a statement. Okay, next, fine, this is okay. Give one word or a phrase. 1 second. Okay, the chemical bond formed by a shared pair of electrons, each bonding atom contributing 1 electron to the pair. Very simple question. So it is mutual sharing of electrons. Sharing of electrons is covalent bond. Okay. Electrode used as cathode in electro refining of impure copper. Always cathode will be the pure one, impure one will be the anode, because the metal will come and deposit on the cathode. So you should use cathode will be pure thin copper rod or copper strip, whatever you can write. It should be pure. Okay, the substance prepared by adding other metals to a base metal in appropriate proportions to obtain certain desirable properties. Alloy. The tendency of an atom to attract electrons to itself when combined in a compound. Electronegativity. Electronegativity. The reaction in which carboxylic acid reacts with alcohol. Okay, this is out of syllabus now. Okay, this is called as esterification, but it is out of syllabus now. Fill in the blanks. Very simple questions. The polar covalent compound in gaseous state that does not conduct electricity. Polar. Okay, gaseous state does not conduct electricity. CCl4, carbon tetrachloride, liquid. First of all, it is liquid and it is non-polar. Okay, ammonia, gas and polar. Okay, methane, gas but non-polar. So it should be ammonia. Salt preparation, not there. Moles, not there. Alkali which completely dissociates into ions, means it should be a strong alkali. Ammonium hydroxide, weak. Calcium hydroxide, weak. It should be lithium hydroxide. An alloy used to make statues, so that is bronze, not brass, not fused metal. Okay, bronze composition is copper and tin, Sn. Okay, brass composition is copper and zinc, main components. Okay, fine. So this is the section 1. So in the next session we'll discuss about the section 2 in detail. Okay, until then, read, prepare well. Okay, all the best.